Welcome back, buddies and girlies. Today we're working through a lab from the NoSQL injection module over at the PortSwigger Web Security Academy, the one called Exploiting NoSQL Injection to Extract Data. Let's read the description. It says the user lookup functionality is powered by a MongoDB NoSQL database, and it's vulnerable to NoSQL injection. Our job: extract the password for the administrator user, then log in as them. They hand us our own account to test with, Wiener with the password Peter. And there's a tip down at the bottom. The password only uses lowercase letters. Hang on to that one. It saves us a pile of work at the end. Quick word on what NoSQL even means, since it shapes the whole thing. A normal SQL database keeps data in tables, rows and columns. MongoDB doesn't. It stores documents, which are basically little bundles of fields, closer to a chunk of JSON than a table row, different storage, and a different query language to go with it. And as we'll see, the injection has a different flavor too. We'll fill in the rest as we hit it. Let's open the lab. First thing, my setup. I've got Foxy Proxy switched on in the browser, routing my traffic through. I'm on Burp Community Edition, the free one, which is all this lab needs. And in Burp, under Proxy then Intercept, I've left Intercept turned off. I've explained it before why, and you are my besto friendo and watched all my videos, so you already know it. So let me log in up the top, my account, and I'll put in Wiener and Peter. And I'm in, sitting on my account page, which shows my username and my email. Now over to Burp, into Proxy, then HTTP history. You'll see a handful of requests fired off just from logging in and loading that page. The one we care about is a GET request to /user/lookup, with user equals Wiener tacked on the end. It's interesting because the account page sent it on its own in the background to fetch my details. Let me break down what we're actually looking at, because if this is new, it all looks like noise. GET is just the kind of request your browser makes to go fetch something. After the path comes a question mark, and that question mark means here comes some parameters. Then user is the name of a parameter. The equal sign assigns it a value, and Wiener is that value. So the page is telling the server, look up the user named Wiener, and that value, Wiener, is the bit we get to play with. That's our way in. Let me right-click that request and send it to Repeater. Repeater is the tab where you take one request and replay it as many times as you like, tweaking it a little each time and reading the response each time, without trekking back to the actual site and clicking around. For poking at an input, it's exactly the tool you want. And the request we just sent over already carries our logged-in session, so we can replay it freely. Let me hit send once for a baseline. There we go. The response comes back as JSON, with my username, my email, and my role. That's a normal hit. Good. Now let's poke. First, what does a name that doesn't exist do? Let me swap Wiener for something junk, like put 69 at the end of it. 69, I am so funny and mature. Send. And we get a little message back, could not find user. Makes sense, there's no such person. Or position. See what I did there? That's our normal miss, the not found response. So notice its shape. Now something bolder. Let me drop administrator in there instead, since that's whose password we're ultimately after. Send. And the server just hands me the administrator's account details. Username administrator, role administrator. So as a regular logged in user, I can pull up somebody else's record just by asking nicely. That's its own separate bug. An access control problem. And it's not even what we came for, but noted. What we want today is the one thing the server is not showing us, the password. Real quick ad break. When I started CyberSec, the hardest part was that everything was scattered all over the place. So I pulled it into one library, 33 modules, foundations through SOC and Blue Team. It is on my Etsy, link in the description. Right, is this input actually injectable? Let me try the simplest probe there is. Name back in place, and I'll add a double quote on the end. Send, could not find user again. The double quote did nothing special. The server just took it as part of the text and went looking for a user whose name literally ends in a double quote. Came up empty. Moved on. Fine. Now the single quote. Same idea, single quote on the end this time. Send, and oh, there's our error. There was an error getting user details. Completely different response. If you're new, an error feels like you broke the thing. You did. That's the win. The single quote did something the double quote didn't, and that's the server telling us the single quote is special to it. And this is worth pausing on because it's not just this lab. It's close to the first thing you'd try on any input field, anywhere. When an app takes what you type and drops it into some code running behind the scenes, that code needs a way to know where your text starts and where it stops. The normal way to do that is wrapping it in quote marks, single or double. So whatever's between them gets read as one solid piece of text and nothing else. Doesn't matter if the backend's talking to a SQL database or, like here, a NoSQL one. The trick is the same. So a quote character is the classic first probe, because if the app isn't careful about it, your quote closes that wrapping early, and everything after it stops being harmless text and starts being something the parser has to make sense of as code. That's exactly what just happened. To see why, let me sketch out what the server is probably doing back there. I'll open my little notey notes I prepared for you little wombats. In my previous video, I was talking about the operators. Please check that video out if you are unfamiliar with them. The link to it should appear in the top right corner. I also left a link to a little documentation in the description for you to check it out. It takes like 30 seconds, so don't be a lazy potato chips who types everything to an AI. So back to our little code. I'm guessing here. I can't see their code, but for a MongoDB lookup like this, the natural way to build it uses an operator called $where. And $where is the spicy one because what it does is take a string of JavaScript and run it against every document in the collection, keeping the ones where that JavaScript comes out true. So the condition they've probably written is roughly this.username double equals single quote, then whatever I type, then a single quote to close the string off. When I send a clean name like Wiener, it becomes this .username double equals single quote Wiener single quote. In plain terms, find the document whose username is Wiener. And that word this, by the way, just means the document it's currently looking at. So this .username is that document's username field. Now watch what happens when the thing I type is itself a single quote. My single quote lands right after the opening quote and closes the string off straight away, way too early. And that leaves the app's own closing quote stranded out at the end, a single quote with nothing to pair with. JavaScript reads that straight quote, sees broken syntax, and falls over. That's the error from a second ago. And here's the bit that makes the whole lab click into place. It's a JavaScript error because $where is literally running my input as JavaScript, which means if I can write valid JavaScript in that box, the server runs it for me. So all the JavaScript operators are in play. Ampersand, ampersand, pipe, pipe, double equals. We can start asking the server actual questions. Before anything clever, let me just confirm that idea, that my input really is being run as code and not just choking the parser. The simplest valid thing I can do is glue an empty string onto the name. In JavaScript, a plus sign joins two strings together. So I'll send Wiener, single quote, plus single quote. My single quote closes the Wiener string. The plus joins it to another string, and the server's own trailing quote closes that second one off as empty. So it's just Wiener joined with nothing, which is still Wiener. One catch first, though. A plus sign is special in a URL. It gets read as a space if I send it raw, so I have to URL encode it. In Repeater, you do that by hand. Select the bit you want to encode and hit Control-U. The browser does this for you automatically up in the address bar, but Repeater won't, so get used to reaching for Control-U. Let me select my payload, Control-U, and send. Wiener's details, no error. So the server cheerfully ran my little scrap of JavaScript and gave a clean result. Confirmed. Our input is being executed. Now the real lever. If the server runs my JavaScript, I can feed it a true or false condition and watch the response change. Let me start with something that is definitely false. I'll send wiener, single quote, and single quote, 1 single quote, double equals, single quote, 2. The ampersand means and, so the document only matches if both sides are true. Side 1, the username is wiener. Side 2, 1 equals 2, which is never true. So the whole thing is false. And don't forget that ampersand needs encoding too. Select it and Control U, same as before. Send. Could not find user. False gives us the miss. Now flip it. Same payload, but make the second side true. Single quote, 1 single quote, double equals, single quote, 1. 1 equals 1. Always true. Both sides true. The whole thing's true. Send. And wiener's details come back. So now I've got an oracle. A true condition shows me the account. A false condition shows me could not find user. Those two responses are how the server answers yes and no to anything I ask from here. One thing that's easy to trip on, the quotes. Notice my payloads keep ending on a single quote? That's on purpose. The server bolts its own closing quote onto whatever I hand it. So I leave one quote open at the end, the server's quote closes it, and everything stays balanced. Forget that, and you get a syntax error instead of an answer. Okay, we can ask yes or no questions, so let's aim them at the administrator and go after that password. We can't read a string until we know how long it is, so length first. Let me just copy this. Okay. I'll point it at administrator and ask whether the password is shorter than 30 characters. Administrator single quote and this password length less than 30, pipe, A equals B. Let me unpack that. This password length is just how many characters are in the password. Less than 30 is the real question. And that pipe, A double equals B on the end, pipe means or, and A equals B is false, so it doesn't change my answer. It earns its place 2 ways. I hope it makes sense. It's a harmless throwaway, and that trailing single quote B gives the server's closing quote something to pair with, so the whole expression stays balanced. Encode, send. Administrator's details. So this means yes, under 30. And notice something while we're here. The fact that asking about this password length gives me a straight answer at all already proves the password field is there. The response itself never shows a password, only username, email, and role. But the field is sitting in the document. The server just isn't sending it out to us. Leaving a field out of the response like that has a name. It's called a projection. And the lovely part is our JavaScript runs server-side, inside the document, before any of that trimming happens, so it can read the password even though we never get to see it. So from here, it's all indirect questions, one yes or no at a time. Now, I could sit in repeater trying 29, 28, 27 by hand, but that's tedious. And tedious is what intruder is for. Intruder fires the same request over and over while swapping in a list of values for you. Let me right-click and send this to intruder. I'll change the question slightly. Instead of less than, I'll use a straight double equals. So each number is a clean yes or no. Is the length exactly this? And I'll drop the or B decoy because now my number sits inside quotes, so the quotes already balance on their own. So the payload becomes administrator, and this password length double equals, and then the number, which I'll mark as the spot for intruder to fill in. In the Payloads tab, I'll set the type to numbers and run it from 1 to 29, which covers any sane length. Start attack. Now the thing to understand about reading these results, every request comes back 200 OK, hit or miss. So the status code tells you nothing. They're all the same. The difference is in how much comes back. A miss returns that tiny could not find user message. A hit returns the full account details, which is bigger. So I sort by length and look for the odd one out. And, oh, there it is. The whole column is the same short length except one row that jumps up, and the value on that row is 8. So the password is 8 characters long, positions 0 through 7, 8 of them, which tells Intruder exactly how many spots to grind through next. Last stretch. Pull the password out 1 character at a time. Here's the idea. In JavaScript, you can grab a single character of a string by its position using square brackets. And I can quiz it. Is that character an A, B, and so on until 1 comes back true. Do that for every position and the password spells itself out. By hand, that'd be brutal, so I'll let Intruder run the grid. The payload is administrator ampersand this password 0 double equals A. But this time I mark 2 spots for Intruder, the position number in the brackets and the letter I'm guessing. And code again as before. For the attack type, I pick Cluster Bomb. Cluster Bomb takes 2 lists and tries every combination. So it pairs position 0 with A, then 0 with B, all the way through Z, then moves to position 1 and runs the whole alphabet again, and on it goes. So, 2 payload sets. Set 1 is the position, numbers 0 to 7, since we know there are 8 characters. Set 2 is the guess, a simple list of the letters A through Z. And remember that tip from the very start? Lowercase only? This is where it pays for itself. I don't bother with capitals, digits, or symbols, just 26 letters. If you're on Burp Pro, there's a built-in A to Z list, but typing them out is no hardship. There's also a slicker route some people take, using this password match with a regular expression. But the bracket by position way is easier to follow on a first pass, so we'll stick with it. Let me just fill out the ABC list. I had to open the ABC Wikipedia after reaching the letter P. I'm so dumb, man. Alright, everything should be Gucci. Let's start attack. I was made for loving you, baby. I'll speed up the process because I love you so much, you tiny, reverent speck of dust drifting in a raging storm. When it finishes, I sort by the first payload, the position, then by length inside each position. Same logic as before. Every wrong guess gives the short response, and the one right guess per position gives the longer one. So for position 0, I find the single row that's longer than the rest, and the letter in its second column is the first character. Position 1, the long row, second character. Down the line, 0 through 7. Read those letters top to bottom, and that's the password. Yours will be different from mine, I think at least. These labs regenerate the password every time, so don't copy my letters, read your own off the results. Now, to actually finish, I take that password back to the browser. Why? Because all this repeater and intruder work happens off to the side, and the lab only ever watches your real browser session. A 200 in intruder doesn't register the solve by itself. I have to log in for real. So in the Foxy Proxy browser, I log out of Wiener, head to my account, and log in as administrator with the password we just pulled out. And there it is across the top. Congratulations, you solved the lab. Let me close the loop on why that worked, because this shape turns up all over NoSQL injection. The server built its query by dropping our input straight into a piece of JavaScript, run by that $where operator. Our single quote broke into that string, which is how we knew the server was treating our text as code in the first place. Once we knew JavaScript was running, ampersand, ampersand, pipe, pipe, and double equals, let us put true or false questions to the server, and the 2 responses, account details versus could not find user, gave us a clean yes and no. We aimed those questions at the password field, which the server kept in the document but never showed us. First to learn it was 8 characters long, then to read it 1 character at a time. Stack up 8 yes or no answers per position, and a hidden password just falls out. That's the lab. Anyone can copy a payload, but understanding why it works is the bit that carries into the next lab. As always, like, sub, comment about your life, etc. I'll catch you in the next one.